LaFarm was created in 2009 by two students, Jen Bell and Mickey Adelman. They hoped to use a patch of previously unused land that Lafayette owned next to Metzger Sports Complex, approximately 3 miles off campus. Their hope was to use LaFarm for educational purposes by integrating engineering and the liberal arts through the environmental studies curriculum, scholarly research, and community engagement. LaFarm has grown in size and resources since its formation in 2009 with an increase in overall land coverage of approximately 3 acres, an addition of a solar-powered irrigation system, and partnering with Bon Appetit to bring the food from LaFarm to students on campus. This growth has been achieved by the LaFarm manager, student volunteers, faculty advisors, and professor-led projects. In our project, we are proposing an addition of a root cellar and a classroom at LaFarm. These two additions would aid LaFarm largely by bringing an on-site storage facility and a multi-purpose enclosed structure that can be used for academics and special events. We believe this will help the farm grow by bringing more educational opportunities along with more efficient farming practices. In the past, classes have worked in conjunction with LaFarm in order to bring about improvements. Professor Brandis, in his hydrology class, worked with the art department to develop the Metzger solar-powered irrigation and swale project. Previous engineering studies capstone projects have used LaFarm as a focal point to develop a produce washing station as well as a greenhouse. In our interview with Lisa Miskelly, LaFarm's current manager, she brought up several issues regarding LaFarm's operations that she felt could be improved. We worked with her to narrow down the logistical details of both the root cellar and the classroom to satisfy Lisa's vision for LaFarm's future. Collectively, we believe that these additions would be both feasible and bring positive change to LaFarm. The goal of our project at LaFarm is to create the framework for the addition of a root cellar and a classroom space. We focus on defining the social, political, economic, and technical needs and benefits of these two additions. A major point of our project is to determine the geotechnical feasibility of building these structures on our proposed site. The goal being that we will have created a jumping-off point for a future project to go into further detail to determine factors such as overall cost. A defining characteristic of LaFarm is the farm-to-table movement, which emphasizes the need for locally sourced food sold directly from producer to consumer. This movement has taken a number of forms, including locally sourced restaurants, farmers markets, and community-supported agriculture. The farm-to-table movement has also developed into the farm-to-college movement that helped to spark the idea of LaFarm itself. The college farm movement has led to the creation of college farms similar to LaFarm at institutions across the United States. These farms are used to provide fresh and local produce to their college partner and serve as academic venues. These farms help to create sustainable food loops that use sustainably grown produce to disconnect the colleges from global food loops that tend to be wasteful. Examples can be found at schools such as Bowdoin and Hampshire College.
The farm-to-table and subsequently the college farm movements have shaped the creation of LaFarm. This project follows the ideals of these movements by strengthening the sustainable food loop that exists between LaFarm and Lafayette by making the system more efficient in providing food to dining services and reducing waste. It also serves to teach its students about the benefits of these movements and sustainable agriculture as a whole. A root cellar will bring an example of carbon neutrality to LaFarm and show how Lafayette is acting to promote its green initiatives. The root cellar would serve as an educational tool by creating an example of a carbon-neutral food storage facility as well as the Earth's natural geothermal cooling processes. The cellar's strategic placement underground accesses the 55-degree temperature set approximately 6 to 10 feet below the surface. For the classroom, we worked with Lisa Miskelly to determine what she thinks it will add to LaFarm and what it needs to be successful. We determined that the classroom space needs to be fully enclosed in order to be used throughout the year, as well as large enough to host different events at LaFarm rather than only hosting classes. The space itself will aid in the creation of academic programs built around the farm. In order to properly establish both a root cellar and a classroom, there were a number of federal and state level policies that had to be followed. In regards to the root cellar, we focused on the Food and Safety Modernization Act that outlined the needs for proper food storage. In terms of the classroom, we focused on the Pennsylvania Public School codes that outlined what a classroom space is and what it is required to have. The root cellar will be placed in the adjacent hill slope that leads to Metzger Field. Even though the slope of the hill is shallow, the cellar will be built down into the hillside. The storage space will sit 7 feet below the surface with the door opening on the face of the hill, leaving the cellar in an ideal position to utilize the geothermal cooling effects of the earth. After speaking to Lisa Miskelly, we determined that the most effective size for the root cellar would be an 8 by 8 by 10 foot room. The walls would be made up of simple cinder blocks and they would be covered in shelving units made out of wood to store the food. The floor would be a dirt finish and then covered in gravel to promote the airflow. A ventilation duct and psychrometer will also be added to both maintain and measure humidity levels as well as temperature. After a discussion with Lisa Miskelly, we determined that the classroom should be an enclosed space that could be used year-round to host classes as well as other events. We proposed a 35-foot by 45-foot structure located on top of the slope above the root cellar itself. The classroom will include heating, lighting, ventilation, and restrooms in compliance with the Pennsylvania Public School Codes. We have determined the basic labor and excavation costs for the project, as well as the basic unit costs of materials for both the root cellar and the classroom. We have not determined a total cost for either project, but we hope that a future class will take what we have done and use it to create a total cost estimate that can be presented to the Lafayette LaFarm Advisory Board, as well as the administration.
Our main goal for this project is to determine the feasibility for a root cellar and classroom to be built on this site. And in order to do this, we decided to look into the subsurface to make sure there weren't any obstructions. With the help of Lafayette College Geology Department and John Wilson, we were able to use ground penetrating radar, or GPR, to be able to look underground in a non-invasive way. The GPR works by transmitting electromagnetic energy into the ground and passes information from two antennae, the transmitter and the receiver. The machine reads the subsurface based on the return times of the pulses of energy. This information is sent in real time to the computer attached to the device, allowing us to actively mark the locations of any anomalies while on site. Our data shown here has each run starting at the top of the hill running down slope, turning at the base to walk approximately 10 meters before turning back up the hill. The stars indicate objects of disturbance, and the distance from the surface is symbolized by the top of the hyperbolic curve. The purple arrows indicate a linear horizon, possibly bedrock, but I'll refer to it as an artifact. We decided we wanted to confirm the depth and linearity of this artifact. The GPR showed that this layer was close at the base and got deeper as we moved upslope. We used an auger drill to confirm this by drilling 3 holes, 2 at the base and 1 5 meters up. We dug into the ground until we hit a solid layer that did increase in depth by 0.3 meters when moving upslope. We originally thought that the hill slope was the natural topography of the land, but based on the GPR and auger data, the underground topography runs in the opposite direction of the slope of the hill. This leads us to believe that the hill slope is man-made and consists of fill. Based on the lack of large interferences to this layer, we believe it is a clay fill. This was an important part of our research because it gave us site-specific details to the hill slope at LaFarm. This data gives us hard evidence to a shallow soil content and that a solid artifact exists running opposite to the slope of the hill. This is important information for determining feasibility, and based on our data, we believe it is possible to build a root cellar here, but more investigation is needed to be done by a future class. The root cellar and classroom would bring both food storage and educational space to the property. We believe that the combination of these structural features fit into LaFarm's beacon for the integration of engineering and the liberal arts, while sustaining the college's green ideals. With this preliminary work done, future groups can continue to improve upon these designs and hopefully break ground on this project in the near future.